Today we're going to talk about these guys, the pyramid and the cone. We're going to continue talking about surface area, so we got to think in terms of the faces. What are the faces on these shapes? One a polyhedron, the other not so much, but we can still calculate surface area as we think of what is this, if we think of the ice cream cone. How much area on the paper that makes up the ice cream cone, and then how much surface area for the circle. Same with the pyramid. How much surface area on these triangle, and then how much surface area on the base. So if we think of it in those terms, think of unfold the pyramid. I've got a base shape and 4 triangles. If it's a triangular pyramid, I've got the base shape, a triangle, and 3 triangles around it. So as we try to figure out how to calculate the areas of those, well, the base, just take the area of the base shape, and then the triangle's area of the base times height, or area is equal to base times height. Now, sometimes we'll be given the height of the pyramid and not the base or the slant height. We refer to this part as the slant height along if we were sliding down the pyramid. So let's just say we don't, we're given this height. How would we figure out the slant height in that case? So we know this. How do we figure out this part? Well, if you're thinking in your head already, well, I'm starting to see a right triangle there. Well, you're on the right track. And it's just a matter of Pythagorean theorem. If I know the base, I know the height's going to be halfway in between there. It's half the base. And then I just use Pythagorean theorem. A squared plus b squared equals c squared. So we'll go through an example where we do that. Otherwise, we can generalize our formula. It's going to be, for a pyramid, the base area. That's what this big B stands for. Base area plus half the perimeter times the slant height. It ends up being half the perimeter times the slant height because we have triangles. Base times height divided by 2. So perimeter times slant height. So all the bases of the triangles times their heights divided by 2. So first of all, let's just calculate the slant height of this pyramid. If we know that the height is 30 and this part is 16, which would mean this base would be 32. So really we've got this triangle, 30 and 16 and L. So 30 squared plus 16 squared equals L squared. So it's always important to know what information we have and what we're trying to find. So 900 plus 256 equals L squared. And that'll be 1156 equals L squared. And so then we just take the square root of 1156, which would be 34. So L would be 34. That would be our slant height for this one. And then we can find the area of those triangles along the side, the lateral faces. So remember, when we think of a pyramid, think of the base and then the triangles on the sides. If it's a octagonal pyramid, we'd have an octagon as the base and then 8 triangles around the outside. Okay, why don't you calculate now the area of this pyramid? We know this part is 4 millimeters and the height is 2.1. So see if you can calculate that. Pause the video and restart it when you're ready to see an explanation. So since I know my base of the square is 4.0, I know this bottom portion will be 2.0 since it's halfway, since the height will be directly in the middle. So 2.1 squared plus 2.0 squared equals L squared. See the math for that. I find out the slant height is 2.9. So now surface area equals the area of the base. So my base is this square, which is 4 by 4, which is 16. And then the perimeter times the slant height. Perimeter is 4, 8, 12, 16. Times my slant height is 2.9 divided by 2, since they're all triangles. And then I add up those two regions. 23.2 plus 16 gives me a total of 39.2 millimeters squared. So then we get into the cone. So we know that we have a circle which is not 2, it's just pi r squared, depending on what our radius is. Now, finding out this lateral face is a little bit trickier. Well, we know that as we unfold this lateral face, this is going to be the circumference, so 2 times pi times radius. And this is going to be our slant height. Now to figure out the rest, we've got to think in terms of the rest of the circle. It's a very odd looking circle, but it's going to do for what we're working with right now. So if we take a look at this, in order to come up with the area of the sector, we've got to compare it to the area of the circle, because we know that this area will be proportional to if we had a complete circle. So the way we calculate that is we need to calculate the sector compared to the full circle. So we know the full circle, the area would be the radius squared times pi, so pi L squared. So if we compare the area of the sector to the area of the circle, and the arc length to the circumference of this whole imaginary circle if it were to continue, which in this case would be 2 times pi times the radius, which in this case is L. So here we have area of the sector we don't know to the area of the circle, pi L squared. Arc length 2 pi R to 2 pi L. So we would do cross products. Area of the sector equals 2 pi L. Or area of sector times 2 pi L. I'll just abbreviate that, times 2 pi L equals 2 pi R times pi L squared. And then we divide both sides by 2 pi L. So that's what we have in the next line there. That's how we get to this part. Then we simplify. Divide by 2, divide by pi, divide by L. So we only have one L now. So the area of the sector is just pi times radius times slant length. So that's where we get our formula for the surface area of the cone. Pi R squared plus this region, which is pi times radius times slant height. And that'll give us just this lateral face. So the pi R squared is the circle, plus the pi RL, which is the lateral face. So if you're wondering where that comes from, now you know. So let's calculate the area, the surface area of the cone now. Remember, surface area is equal to the circle, pi R squared, plus our lateral face, pi RL. So pause the video, restart it when you're ready to see a solution. So surface area is pi R squared plus pi RL. Slant height is 11, and the radius is 6. So if that's the case, I got pi R squared. The area of my circle is 36 pi, and my lateral face is pi RL, so 66 pi. Add them up, I get 102 pi inches squared exactly, or approximately 320.4 inches squared. So today we finished talking about surface area of a cone and a pyramid. I looked at how those formulas work as we built off of what we learned previously about surface area of prisms and cylinders.